Hi, this is Dr. Robinson, and we are going to continue our studies. So today we're going to deal with scientific notation. This time we're going to be dealing with addition and subtraction of scientific notation. So here are the steps that you need to know. Step 1, make sure that the exponents are the same before you add or subtract in scientific notation. Step 2, adjust the coefficients if necessary to make the exponents equal. As a rule, we leave the larger exponent alone and deal with the smaller exponent. We're adjusting that to make it equal. So by doing that, we're going to have to move the decimal point of the coefficient. If we move the decimal point to the right, that's going to increase the value of the coefficient, and that has a reverse effect on the exponent. It makes the exponent smaller. Whereas we move the decimal point to the left, that's going to decrease the value of the coefficient, and that's going to make the value of the exponent larger. So there's many places as we move the exponent at the decimal point, that's how many places we move the exponents, because that's multiplying or dividing by tens or powers of 10. So to add or subtract, step 3, add or subtract the coefficients, rewrite the powers of 10. So those are the steps to add and or subtract in scientific notation. Remember, scientific notation is a way to abbreviate very large or very small numbers using the power of 10. Note the magnitude is the size of a mathematical object. A number, when you write it in scientific notation, it consists of two factors, two parts. The first factor or first part is a number that's greater than or equal to 1, but it's less than 10. It's going to be multiplied by a second factor, which is a power of 10. So let's try an example. Here we have to find the sum of 3.769 times 10 to the 5th. Plus, we're going to add to that 4.21 times 10 to the 5th. Okay, our steps were to make sure that the powers are the same. The exponents have to be the same in order to add or subtract. So yes, the exponents are the same, so that's going to give us the same exponent. We're just going to rewrite that. So that'll give us 10 to the 5th. Now we have to get our calculator because we got to add the coefficients. So we're going to add up the first numbers, 3.769, and we're going to add the second coefficient, which is 4.21. 4.21. And that'll give us a total of 7.979. And that's our new coefficient, 7.979. And there is our coefficient. We're going to multiply that by the power that we found to be the same, which is our power of 10. Now remember, in scientific notation, the first number's got to be a power, between 1 and 10. So 7 is definitely between 1 and 10. So it's going to be fine by leaving it just like that, because that is a power between 1 and 10, and the second part is a power of 10. So that is our answer, 7.979 times 10 to the 5th power. Here's one for you to try in your spare time. See if you can find the sum or the difference when you have 4.21 times 10 to the 5th minus 3.769 times 10 to the 5th. See what you get. Check your understanding. See if you understand it so far. If you're still uncertain, rewind the tape. Write down your questions. I'll be glad to answer them in the next class. Okay, here's one we have to add. 5.4 times 10 to the 3rd plus 1.2 times 10 to the 5th. Now these we cannot add because I notice this is 10 to the 3rd power and this is 10 to the 5th power. So I have a problem. I have to deal with different exponents, but I cannot add them because the exponents are different. So I need to make them the same. So the rule is leave the bigger exponent alone and work with the smaller exponent. So I want to make this 10 to the 5th power because that's the exponent that I need, but I have 5.4 and I need to make that exponent bigger. So if this is going to go up, the value of the coefficient is going to go the opposite direction. So if this exponent went up by 2, so it went up by 2, the value of the coefficient has got to go down by 2. So I'm going to go down by 2 places. So I'm going to move this over 1, 2 places, add a 0, and there is my new number for this value. It's 0.054, and that's going to be multiplied by 10 to the 5th. So that's what it is if it were going to be to the 5th power. Now I can add that to this because they're the same. So my answer is going to be 10 to the 5th power. And I can now get my calculator out and add those two coefficients. So let's clear this. This coefficient now is 0.054. And now I'm going to add to it the second coefficient, which is already to the 5th power, because remember, I cannot add unless those exponents are the same. So I now made them the same, so I can now add these up, and I get 1.25 for 1.254 times 10 to the 5th power. So that's going to be my answer when I get my exponents to be the same. And remember, scientific notation's got to be between 1 and 10. So that number is now between 1 and 10. Now let's backtrack on what we did. We changed this from a 3 to a 5 because we couldn't add them because the exponents are different. So now that they're the same, by adding 2 to this exponent, I have to adjust the value of the coefficient by moving the decimal point 2 places to the left. Because if the exponent got bumped up, that means the coefficient gets bumped down. So it goes the opposite way. So this becomes 0.54 instead of 5.4. And when I multiply that by 10 to the 5th power, that'll still give me the same answer as if I had this. So now I can add my coefficients, 0.54 and 1.2, so I can add my coefficients together, and that'll give me 1.254, which is now my new coefficient, and I leave my new 10 to the 5th because I had to change in order to make it the same power. So that's a nice job on that. So I hope you understood that. Here's a nice question on subtraction. Again, you cannot subtract because the values of the exponents are different. So try to subtract it, see what you get. It's a good problem. Check for your understanding. Hopefully you understand it. If not, turn the tape back and watch it again. If you're still uncertain, watch your video again and write down your questions. I'll be glad to answer them in class. Here's another question we'll pick up for tomorrow in our class, so give it a shot. I think you'll get it. Again, I hope you got something out of this. I am Dr. Robinson, your mathematics teacher, so write me, and I'll see you in class. Bye-bye.